Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're talking about a foundational math topic that you've probably been doing for a really long time and probably still do a lot of every day in math class, but as these things tend to go, you probably do it so frequently that you forget what it's legitimately called. So today we're going to put a face to a name, so to speak, and talk about simultaneous equations. So let's take a look. Okay, simultaneous equations. That sounds pretty complicated. What does that even mean? Well, if we break down the two terms, we can get a pretty clear picture of what we're trying to do. First of all, the word simultaneous, well, that just means two things happening or some things happening at the same time. Simultaneously means coinciding. And then equations, well, we're familiar with equations. That could be a function, could be y equals x squared, y equals x plus 2, anything like that. So when we talk about simultaneous equations, all that means is we have more than one equation going at the same time. So if we had an instance where we had something like y equals 2x plus 1, and y equals negative x plus 5, those would be simultaneous equations. And so what does it mean when we have intercepting simultaneous equations? Well, if we were to look at something like what I've done here with 2x plus 1 and x minus 5, just go a quick drawing there, 2x plus 1 would look like that, and negative x plus 5 would look like this. We have an intercept. So when they intercept, visually, that's saying when they are the same thing. And when two equations are the same thing, that's what we're going to call the solution. And so in a situation like this, where we have straight lines, there is one solution. Maybe in a later video, we talk about what happens when there are no solutions between two lines. And when that's the case, there's a word for that. And maybe you're saying that by yourself at home. And another instance, maybe we have a line that curves like a parabola. And then we have a straight line, and you can actually see two solutions. So the solutions to two or more simultaneous equations is when they are the same and visually cross. So now that we've defined what simultaneous questions mean, let's take a look at an example and how we recognize it in context. So there are a lot of ways to see this presented on a test, and there are also a couple of ways to solve simultaneous equations questions here. What I've done here is just sort of given you a general, very basic simultaneous equations question where they just basically give you two equations and they say, solve it. And so there are really three main ways of solving these simultaneous equations questions. Those are elimination, substitution, and graphing, which is another word for just sort of drawing, I'll say. So we have 3m plus 2 equals 24 and 6m plus 6 equals 60. And I'm going to go through each of these three ways to solve and show you that we're always going to get the same thing. So of elimination, you've probably seen this in school, and what some people will do is multiply one of them by a negative value and then add together. I don't like having to distribute a negative, so I'm just going to double this guy right here, because the goal here is to reach a point where one of these variables is the same in both. So if I double 3, I'm going to get 6, so I have 6m plus 4p equals 48, and if I just subtract one from the other, that's going to give me 6m minus 6m is 0, 6p minus 4p is going to be 2p, and 60 minus 48 is going to be 12, which is good to say that p is 6. So that's elimination. That's one way to do it. Let's talk about substitution. So I'll clear this out. And something you may have seen at home is 6m plus 6p equals 60. I can just go ahead and divide that by 6 and get m plus p equals 10. And then what I can do is substitute. So I want to get one letter by itself first. So we're going to say that p is equal to 10 minus m. And what I can then do is just throw that right into there. And what that's going to do is give me 3m plus 2 times 10 minus m equals 24. I just distribute there. 3m plus 20 minus 2m equals 24. And that's going to tell me that, okay, so 3m plus minus 2m is equal to m plus 20 equals 24. So m is 4. And so in my previous equation, I found that p was 6, right? So I'm going to say that, well, 4 plus 6 is indeed 10. So in this case, m plus p is consistent, because that's using substitution. And so with our final solution here, we're going to use graphing or just drawing. So the best way to do that is going to get to have these both in the form of a standard linear equation, because I don't really know what either of these look like in this present form. So we'll just rearrange. Well, we'll have them both in the form of m equals. So we'll say, again, m plus p equals 10 here. So that's going to be m equals negative p plus 10. And over here, we're going to say that this is, so we're going to have 3m equals negative 2p plus 24. Divided by 3 gives us negative 2/3 p plus 8. And we basically want to see, all right, we have this line, negative p plus 10, which is going to look like that. I mean, this negative 2/3 p plus 8, which is going to look like that. And if we wanted to graph that out with our graphing calculator, we would probably get that same 0.46. And if we just wanted to set these two lines equal to each other, we would have negative p plus 10 equals negative 2/3 p plus 8. And then we're just going to add p to both sides to get 1/3 p. Then we'll subtract 8 from both sides to get 2. And so then we multiply by 3 and we get p equals 6. And so we can see here, once again, with all three of these solutions, we get p equal to 6. So any of these are effective. It's all about comfort and what's going to be the quickest solution for you in the context of the problem. All right, moving on, let's do a couple of practice problems. We've got 3 here today, which is a bit of a departure from the norm, but there was one kind of question that I just could not resist putting in here. So take a look at this first one and see what you can do. Okay, let's take a look at the first one. So per usual, when we have a long word problem, we look to the end first, and it says, which of the following systems of equations best represents the situation described above? And so what we're basically going to do is turn all these words into some math. So in a school's photography club, there are 2 types of members, novice and experienced. The total number of members in the club is 60. So it looks like they're doing X and Y here, but probably if this were me, I would say N plus E equals 60. Experienced member pays $30, while the novice pay $20. So then we can call that 30 times the number of N plus 20 times the number of E is equal to 1,500 in membership fees. And now I basically just need to figure out which one matches up with that. And it looks a lot like it's going to be this one. So a pretty straightforward start there. Let's see if we get any more interesting. Okay, now let's try number 2, see what you can do with this one. Okay, let's take a look. So it asks, which of the following is a potential solution to the system of equations below? And what we have here is a circle and a coordinate plane. So if you haven't seen that one, go back and take a look at the video where I explain how that works. And the next here we have this 2y minus 4x equals negative 10. So the first thing that we're going to want to do is turn this bottom equation into something that I can work with, because currently I just have this, standard form linear equation. I want to go to more of a y equals mx plus b form. So I'll put the 4x over there, and I'll have 2y equals 4x minus 10, and then I'll probably just divide by 2 so that I don't have this 2y value. 2y equals something value. So that's just going to be y equals 2x minus 5. And now what do I do? Well, I have an x in here and a y in there, and what I can actually do is just go ahead and put this right here. And what we'll be doing here is substitution. So I'll put this over to the side, because what we're doing here is, since we have, a square, we're going to potentially have 2 solutions, but it just says what's one potential solution for them. So we'll see what we can get with that. So we're going to have x minus 1 squared plus 2x. So 2x minus 5 minus 2 is just going to be 2x minus 7 squared, and that's going to equal 25. And then what I can do is sort of use my foiling principles. So also lots of references to previous videos today. We can go back to that x plus y and x minus y squared video to know how to do this quickly. So x minus 1 squared is going to be x squared minus 2x plus 1, and 2x minus 7 squared is going to be 4x squared minus 28x minus 49, and that's going to equal 25. And now I'm going to add everything together. So I have an x squared and a 4x squared. It's going to give me a 5x squared. Negative 2x squared minus 28x squared. Negative 2x minus 28x is going to give me negative 30x. And 1 plus 49 is going to give me 50. It's going to equal 25. I'm going to go ahead and move my 25 over here so that I am going to have it equal to 0, because when we're solving for quadratics, we're always going to want to make our equation equal to 0. That's going to give me 5x squared minus 30x plus 25. And then I can go ahead and divide by 5 to get x squared minus 6x plus 5 equals 0. And that's going to nice and neatly factor to -1 and -5. And so my x solutions are either going to be 1 or 5. And looking at my solutions here, that's going to get rid of everything except for b and d. And now I need to decide whether y is going to be 3 or -3. And that's really straightforward. I just already know y equals 2x minus 5. And so then I'm just going to put in 1 right there. 2 times 1 minus 5. And that's going to be -3. So that's quite a bit of work, and honestly, this is derived from a question I found in a non-calculator math section of the SAT, so you could absolutely expect to have to do something like this on the test without a calculator. But just remember that whenever you would have to do something like this, it's going to be an integer solution. You're never going to have to be doing fractions or the square root of anything upsetting, so it's all pretty reasonable in the grand scheme of things. Okay, moving on to the last one here. Give this one a try and see what you can do. Okay, I'm a big fan of this question, so the big important thing to notice here is that this is asking for two things at once. So whenever a question asks you for two variables at once, there's going to be a really nice shortcut to get there. And in this case, maybe you at home try to solve individually for these variables, but what you may notice is if you add these two things together, 2g plus 3h and 3g plus 2h, you're going to get 5g plus 5h, and that's going to equal 50. And the nice thing we can go ahead and do is just divide that by 5 and get g plus h equals 10. And 10 is what they want. So we are actually done because we've solved for what they want. We don't actually ever need to solve for individual variables because that's not what they're asking for. Okay, that's it for this video. Remember, with simultaneous equation problems, there are three main ways to solve them. Those are draw, substitute, and eliminate. And before you dive into one of those simultaneous equations problems, make sure you've decided which one is going to be the most effective route to get to a quick and easy answer. Anyway, if you found this material useful, we hope that you will like and share the video and subscribe to Quad Education. Reach out to us if you have any need for tutoring. Thank you for watching, and I hope you have a great day.